Alright, so here we have an FMI pump. This one is actually set up for variable flow, but this is applicable for variable flow and fixed flow FMI pumps. So one issue that can come up from time to time is an issue where the external fuse on your FMI pump seems to blow. The concept that usually causes this, because it's directly in line with the red wire for the FMI pump, is that the FMI pump itself is drawing more than 4 amps. Now, we know that it should be drawing no more than 4 because right here on the sticker it says 12 volts, 4 amps max. So that's what this pump is rated for. Anything beyond that, you're risking damaging the motor inside this pump, which in turn damages the whole pump. So to alleviate that, we have these inline fuses that are rated for 4 amps. But if you have one that keeps blowing fuses, and you're kind of curious to know why, one thing you can always do is measure the amperage that your pump is drawing. Now this is in relation to another video, which I'll link in the video description below, cleaning the wet end of the FMI pump. If the collar that spins this wet end over here gets bound up with chemical, or if it doesn't get flushed properly, or if the wet end just needs general cleaning, as the pump is trying to spin, it's going to have to work harder and harder and harder. And that requires more and more amps. If the amperage that it takes to actually spin the piston, if that amperage is higher than 4 amps, it'll obviously blow the fuse and is not good on the motor for that pump. So how do we measure? Well, that is why we have digital multimeters. In this case, I'm using a Fluke 117. You don't have to have anything that fancy. Anyone that has an amp meter built into it for DC is good enough. Now on this one, the idea is kind of the same that you would find on most multimeters. First thing you want to do is you want to take your red lead, take it out of volts, because we're not talking about volts now, we're talking about amps, and put it into the amps column. And then the next thing we want to do is we want to look for an A with straight lines and dash lines, not A with a straight line and a curvy line. That's for AC current, which we're not dealing with. We're dealing with DC current. So we flip it down to amps DC. We have our red lead in here. So the next thing we want to do is, with the fuse out, we're going to try to prime the pump in override. So make sure your switch is on override and make sure the prime is on. Now, prime being on, nothing's going to happen, obviously, because there's no fuse in there. But what we can do, so long as we got power to everything to turn the prime on, we should be able to take our black and red lead from a multimeter. It doesn't matter which side goes into where on the fuse tap or the fuse holder, it just has to go. So with it in prime, let's see what happens. Now, if we have it in one direction, it'll show a negative number. If we have another direction, it'll show a positive. But either way, the numbers are still relatively the same. So I can flip this around because you saw that was negative numbers. And look, it still works. Now, note that what we're seeing here is 2.2, 2.16, 2.5. As it goes, it cleans itself up a bit, so the values start to drop. But at prime, we're seeing somewhere between 2.1 amps being drawn. And that's at full bore prime. That's not too bad. So here's something else we can try, and this is kind of to illustrate that point about when the pump binds up. As I apply pressure to the back end of this pump here, as a very viscous or gritty chemical would do, notice that my amperage rose. That's me just putting a little bit of pressure on it. And now it's already up to 3.4 amps. As I let go, pressure releases, the numbers go down. So if something were to really gum this guy up, and you see right there, I got it all the way up beyond 4 amps, which is not even good on the thing. For a split second, it'll be okay, but that's kind of my point, is any kind of amount of force that stops this piston from spinning is going to cause this fuse to blow, and if it gets too high and lasts like that for too long, it'll cause this guy to blow, and when this guy's dead, the whole thing's done, you need a new pump. So one way to check to make sure is, like I said, measure those amperage readings. If you notice that your amperage readings are kind of high, then I would suggest looking at that link in the video description for cleaning the wet end as the first troubleshooting move, because as you clean out the wet end, it'll make the piston spin a lot more free, a lot more easier. Also, if you haven't been flushing on a regular basis, I would suggest that you do, because flushing will also clean up the wet end from having too much bindage and blockage in the back. So I hope this video helps. If you guys have any questions, don't be afraid to contact your ADAPCO service tech at 855-782-3378. Thanks.